Hey guys, it's Cade Nelson with Apposite Technologies, and today in this video I am going to show you how to configure the RFC 2544 module for the Netropy Traffic Generation Solution. Let's start out with what is RFC 2544. RFC 2544 has been around a long time. It was published in 1999 and it was developed by the Internet Engineering Task Force to standardize methodologies for benchmarking the performance of network interconnected devices like routers and switches. It's critical for verifying your reliability, optimizing network efficiency, and identifying any bottlenecks before deploying. It measures key metrics like throughput, latency, packet loss, and jitter under controlled conditions. This ensures that the network infrastructure meets the performance standards and supports the quality of services for the applications. In this demo, I'm going to do a very simple demo of testing a switch, or as labeled here, device under test. I am just going to plug port 1 into one port on the switch and port 2 on another port of the switch, and then I'm going to start my 2544 test. So let's see a demo. Okay, so let's configure the Netropy Traffic Generation to use the RFC 2544 module. So if you remember in the diagram I showed you, we're going to be using port 1 and 2 to send data through the switch. Once I've reserved the ports, I'm going to go ahead and create the test bed, and we have all these different modules to choose from. In this case, I'm going to be running a 2544. So let's call this demo vid and go ahead and create this new test. Okay, once I've created the test bed, I can go ahead and configure it. And if you're already familiar with the Netropy products, you'll know that all of our products follow a 4 to 5 step process when configuring. No different with the 2544. So go ahead and add these two ports to my testing. And now we can configure what IP addresses we're going to use and how many IP addresses we're going to use to run through this switch. I'm going to keep it pretty simple. I'll just do 128 clients. And you can see that we call these transmitter configurations and receiver configurations. So you can also think of transmitter as west and the receiver as east, which you'll see later on in the reports. Here, I'm doing a very simple layer 2 test, so I don't need to have any external gateways or anything. I'm just running right through a layer 2 switch, so I don't need to change much here. Go ahead to the next, and now we can decide all the different types of tests that we can run. And I've run a test earlier that has all of these, but to conserve time, I'm just going to do a throughput test. But I wanted to show you everything you could choose in here. So for throughput test, we can test all these packet sizes, or we can do a custom packet size. For latency and jitter, again, we can do all of these packet sizes or a custom packet size. And again, for frame rate and loss test, we can choose all of these or put in our own custom packet size. So for this test, I'm simply just going to do 1280 and 1518 size packets for throughput, and we'll do 2 iterations for 10 seconds, and we'll go ahead and start the test. We need to add a stream. I'm going to do IPv4 as my test. You'll be able to do IPv6 and other types of tests in the future. So now we're going to get a quick summary, and I'm going to go ahead and start this test. So this test is going to take a few minutes to run, but while it's doing that, we can go ahead and look at some of the statistics. So right now, if you understand the RFC 2544 structure of testing, we're testing in one direction. So we can see we're sending in one direction and we're receiving in one direction. And right now we're sending at 1 gig and we're receiving at 1 gig. So this is expected behavior. All my iterations were for 10 seconds. So each of these little tests will run for 10 seconds. So right now we're running in one direction for 10 seconds. And down here it shows our throughput. which we can see is at 1 gig. It also shows our packets per second, and we can see it step down every 10 seconds or so. Now we're going the opposite direction. I'm sending out of port 2, receiving on port 1. We also have our latency, so when we start and stopped at our test, we did have a little burst of latency there, so this switch is not reacting quickly when we're bursting our traffic through it. We might be able to see a little bit of test statistics right now. Yeah, so we can see our throughput test. This is getting 1 gig at 1200 size packets, and we also got 1 gig. Okay, the test is over, so we can go ahead and look at the results now. First thing it's going to do is bring up our offline analyzer, which gives us our graphs of our tests here, and we can look at things. So we did see something a little strange here, so I can zoom into that. I could also come in and annotate on this, so maybe something weird happened, and I can go ahead and make some notes. I'll add some text. You see what happened here. And then I can save this as a JPEG, PNG, or PDF and send it off to someone else, maybe even the manufacturer of the switch, and say, hey, we're running an RFC 2544 test, and at 10:43, we're seeing an issue go on here. We also have all these statistics as well, and some aggregate statistics we can see here. But more importantly, we have this log file. I'm going to go ahead and download this log file. It's going to give us a quick little printout of how this test was configured and the information in the test. So we can see we used port 1 and 2. We only did throughput test. And then we have our throughput test results. Here we see port 1 to port 2. And then we just hit 2 different frame sizes. And we can see that we pretty much got a gig in both directions. And then in the opposite direction, we have the same result as well. And then it gives you a quick summary. Okay, so I know that's not too interesting. So I actually ran a test earlier that has a little bit more information. So let's go in here. Okay, so here I have a test I ran earlier in the day. I ran it a little bit longer. And if we scroll down, we can see that I did all of the tests available, the throughput, latency and jitter, and frame loss. So let's come down and look at the results on this one. So first we have our throughput tests. And just like the other report, you can see port 1 to port 2, and you can see the performances of these lower frame size. Obviously, the lower the frame size, the less performance we got out of the switch. And then the higher the frame size, we were able to finally get into the 1 gig speeds. Same with port 2 to port 1. But then in my other tests, I did not do a latency and jitter test. So here we can see that we only ran a 10-second test 10 times. And we have our average latency, our minimum latency, our maximum latency, and average jitter. And we can see that we really didn't have much latency at all. Worst case scenario was almost 7 milliseconds. And this was port 1 to port 2. So below we have port 2 to port 1. And we can see the results there. And then moving on to the next test, we have the frame loss test. So over on this side, we can see the frame size. And we can see that the loss was nothing on either one of these. All the losses were nothing. So this obviously passed. Then we have the graphing from port 1 to port 2. And then port 2 to port 1 graph. So it gives you a quick little summary of how your device performed under this 2544 test. I think the report is really easy to read. And by doing a quick look at it, you can tell if you've met the standards for your production. Please let us know if you need any other questions.